Okay, graphs. So hopefully you've seen the video on displacement graphs, and I want to talk with you about velocity graphs. We're going to do the same sorts of things. We're trying to make a story out of it, understand what's happening, and see how that represents the real world, which we're trying to represent. So here's an example of velocity graph. So a couple things to notice that more common for us to have negative velocity. So I'm going to put a 0 point in the middle. Again, I'm going to have positive velocity and negative velocity is going to be common. What I'm showing is time. Time is always going to be on our x-axis in physics, so it doesn't matter if it's dependent or independent, right? You can't manipulate time, so it's one way to think about it. But anyway, it's always going to be on the x-axis. So this is how velocity changes over time. And I'm going to look at a few things. So the first thing I'm going to look at, so I start out with a positive velocity, and that stays constant. And then instantaneously, I switch to a negative velocity. And I can't really do that in real life, but it's a graph, so let's make it work. So I'm going to switch to a negative velocity and have that negative velocity for a period of time, and that's sort of the end of it, okay? So I'm going to go through my thought process, and I want to think about two things for every graph that I see, every motion graph that I see especially. So I want to think about what does the slope tell me and what does the area under the curve tell me, right? So first, slope. So slope, rise over run. So rise over run. So I'm going to have my velocity, right, over time. So how does my velocity change over time? You think about it in terms of units, right? I have meters per second. So we'll call this meters per second squared. Anyway, I'm hoping that pretty quickly you recognize as the change of velocity over time, or the unit meters per second squared, that's going to be acceleration. So what is my acceleration here? So I'm going along at constant velocity. Constant velocity, my acceleration is going to be 0, right? So my slope of my line is 0. There's no acceleration. I'm going at constant velocity. I instantaneously change. Yeah, there must have been some acceleration in there somewhere, but we're going to skip over that. So instantaneously I change, and now I have negative velocity, but my slope is 0, right? Okay, so the slope is going to tell me acceleration. Let me think about the area under the curve. And the way I'm thinking about this, the area under the curve is going to be, well, what's my rise times my run, right? So the way to think about it, so there's this area here. What does that represent? Well, let me think about that. So I'm going to have my velocity times time, and I think about it in terms of units. I'm going to have meters per second times seconds. Right, and so I'm going to end up, well, the seconds are going to cancel, end up with meters, which is going to be displacement. Right, so it's going to tell me how far I've gone. So if I look at this, I'm going to see, well, how far have I gone? Well, I've gone in a positive direction. I've gone this chunk, whatever this is. Same thing down here. I'm going to say, well, how far have I gone? Well, I don't know, we can call this, let's put some numbers on here. So I'm going to call this 10 meters per second. I'm going to call this negative 10 meters per second. And I will say this is 5 seconds, this is 10 seconds. Okay. So here, if I've gone 10 meters in 5 seconds. So my area under the curve here is going to be 50 meters per second times seconds, which is meters. Down here, how far have I gone? Well, I've gone 10 times 5. So I've gone, my area under the curve here is also 50 meters, but notice I had negative velocity, so technically this is going to be negative 50 meters. Right? So this tells me something. So by looking at the velocity graph, I can figure out acceleration, right, from the slope, and I can also figure out how far I've traveled. So in my 10 seconds, I've gone 50 positive meters and 50 negative meters. Good grief, I ended back where I started from. So I can make a story about this, right? So what's happening? Here I am at my tiny 20 micron house, and I could start wherever. I don't know. I'm going to start here, and I'm going to go out 50 meters, and I'm turning around, and I come back 50 meters back to where I started from. Thing that you can do with this as well is that we can, from this graph, figure out what a displacement graph might look like, or an acceleration graph. So let's look at a displacement graph. So let's make a displacement graph for this. So I'm going to take this graph above, and I'm going to think about how displacement changes over time. And here's what I want to do. So I'm going to put my same axes on here, right? So it's still time. So this is going to be my 5 seconds. This is going to be at my 10 seconds. And I already know that I go 50 meters. So we'll call this 50 meters up here. So if I start at 0, right, you get to decide. So notice this velocity graph doesn't tell me anything about the starting point. Right? So you get to decide, and I don't know. So I'm going to put it at 0 because it's easy. So if I start here, then I've gone 50 meters. If I started at 20 meters away, I will be 70 meters away at that time point. Right. And I go at a constant rate. So that means I'm going to make the slope of this straight edge. The slope of this is going to be flat. I go to 50 meters. What happens for the next 5 seconds? Well, now I have a negative velocity, so that means I must have a negative slope. And I go negative 50 meters. So from here, I go back towards the origin 50 meters, and I get back to 0. So I'm going to connect these 2 points, and I'm going to end up back here. So we can figure out or construct, right? These two graphs are telling the same story. Right? There's a smidgen of difference between them, but they're telling the same story, right? I started at my house, and I steadily walked 50 meters away at a rate of 10 meters per second. Notice that's also the slope here, right? So the slope of this line, my slope, I walked 50 meters in 5 seconds, or 10 meters per second. Here, my slope was my change in displacement. I went from 50 to 0, so I moved negative 50 meters in positive 5 seconds, or negative 10 meters per second. Hopefully you recognize that's showing up on my graph. So these two graphs are aligned on everything, right? So I'm moving away, and I come back to where I started. The only thing I'm not sure of, the only thing that I made up was the starting point for displacement. Everything else is consistent. Okay. Let's look at another example. So let's make it a little bit more complex. So we'll do the same sort of idea. We'll make a displacement graph and try to interpret this. So I'm going to think about this. What's happening here? So I'm traveling some distance. I don't know. Let's put some numbers on here. 10 meters per second. This can be 5 seconds. This can be 10 seconds. We'll call this 12 seconds. And let's figure out what this is going to look like. So I'm going to do the same steps, but I'm going to break this into chunks to make it easier. Right? So I'm going to think about, what does the slope tell me here? My slope is going to tell me how velocity changes over time, or meters per second, if you like units, or meters per second squared, and this is going to be acceleration. And the area under the curve is going to tell me, what is it going to tell me? It's going to tell me velocity times time, right? Velocity times time. And if I think about units, this is going to be meters per second times seconds. My seconds will cancel, and I'll be left with just meters, which is going to be displacement. Okay, so what I want to do is I want to figure out, well, I don't know, I've got 1, 2, 3 things, 3 shapes I can figure out. So let's put some numbers against this, right? So I'm going to have this shape. I can figure out how far I've traveled in that time. I'm going to have another shape in here. Figure out how far I've traveled in that. And I have a third shape in here. I can figure out how far I traveled. So I'm going to figure out the size of a triangle. It's going to be 1/2 base times width, right? So this is going to be 1/2 of my 5 seconds times my 10 seconds. Base times height, maybe I should say. Base times height, maybe that's better. Right, so this is going to be 25 meters, right? So this tells me in these first 5 seconds, I've traveled 25 meters, right? I started at rest, though. So notice my velocity is 0. So I started at rest, and I ended at 25 meters away. In this section here, I want to find the area under this curve. So this is going to be my 10 meters per second times the 5 seconds that I was there. So my area is going to be base times height. Let's call this 5 times size. It's going to be 50 meters. And my area here, this is a triangle. So I'm going to figure out 1/2 my base, we'll call that 2, times my height, we'll call it 10. And that's going to come to 10 meters. So the total distance I traveled, total displacement, is going to be 25 plus 50 plus 10. I have 85 meters. Notice that there's no negative velocity, right? So I'm not going back to the same place I started from. So my velocity starts at 0, my velocity ends at 0, but my displacement continues to be positive the entire time, so I end up further away, right? I start going away, I keep going away, and then I slow down, but I'm still heading away. So, some of these graphs can be a little bit deceptive or a little bit tricky to look at. So in this one, all of my velocity is positive, so all of my displacement is going to be positive. Okay, so let's figure out. So, oh, good grief, I put on here. Well, we'll figure out. So I'm gonna have displacement times time. I'm gonna make the same time points. So here, 5 seconds. I should be able to put a mark. 10 seconds. Just put another part. And 12 seconds. We can line these up so that it fits. So after 5 seconds, right? How far have I gone? 5 seconds. I've gone 25 meters. After 10 seconds, I'll have gone 75 meters. And after 12 seconds, I'll have gone 85. So let me put, I don't know, 85 at the top here. I'm just going to have to estimate this. So I'm going to call this 75. I'm going to call this 25. Right? Close enough. Right? So after 5 seconds, I've gone 25 meters. After 10 seconds, I'll have gone 75 meters. After 12 seconds, I'll have gone 85. So how I connect these is a little bit tricky here. So I'll start with the easy one, right? Here, my velocity, it's constant. So constant velocity means a straight line. So between these 2 points, I have a straight line. Right? My velocity starts at 0 and increases to this, right? So I'm going to have sort of a curve here. And my velocity at the end is 0. So at my end, it needs to be flat. So I'm going to go sort of a curve this way. Anyway. And this now represents a displacement graph for this velocity graph. All right. So really important that even though my velocity is negative, right? I see my acceleration is negative. My velocity is still positive. It's just decreasing, so it's less positive. So notice my displacement continues to get further away. Okay. So it's one way to look at velocity graphs. You can get to 2 things from velocity graphs. It's really common to look at a velocity graph and try to figure out 2 things from that. One is displacement. You should be able to come up with a displacement graph. And the second one is acceleration. We'll look at acceleration next week. Acceleration graphs. Hope that's helpful. Bye.